My name is Vince Cerf. I'm Vice President and Chief Internet Evangelist at Google. And with me today is John Brzezowski, who is a longtime IPv6 maven, to say nothing of a very, very long connection with the Internet's evolution and implementation. So, John, thanks for joining me today.
It's an honor, Vince. Thank you.
So our topic today is IPv6 on by default, but I want to take you back to June 6, 2012, when we made a big announcement basically saying IPv4 is over, it's time for IPv6, the era has begun. That was 10 years ago. Here it is, 10 years later, and as far as I can tell, we still haven't got more than maybe on average of 30 or maybe 35% implementation writ large. In some places, it's very heavily implemented. Some organizations have full up IPv4 and IPv6 capability, and some have very little. So we should talk a little bit about that. But I'd like you to refresh my memory for a moment. When we made this big announcement on June 6, 2012, something followed called Happy Eyeballs, which was sort of a way of testing whether your V6 connection was working. When did we announce that then, or was that later? And what did it do for people?
Then it was, if I can quote a good friend of ours, Stuart Cheshire from Apple, who I spoke to in advance of our discussion here. Happy Eyeballs, Apple and Google and others had a heavy hand in the creation of it. And if you look back then to 11 years ago, World IPv6 Day, which was preceded by World IPv6 Launch, a lot of the learnings that came into those two events really fueled the innovation around approaches and technologies like Happy Eyeballs. While there was awareness and implementations being born leading up to World IPv6 Launch, which was kind of the decade-long, a decade ago event that we're celebrating, many of those implementations really took root after World V6 launch itself, and frankly changed the game as far as adoption was concerned. It really made this idea that if there was anything wrong or impaired about a V6 implementation, that it wasn't going to affect adoption in any way, and it has truly done just that. It was a huge game changer for the acceleration of adoption.
Well, certainly a number of companies, mine included at Google, offered quite a range of services accessible through IPv6, including various streaming video kinds of applications. So it was a really good test of our implementation. Well, let's talk a little bit about what the consequences are of turning IPv6 on by default everywhere. The first observation, I guess, is that does it still work, or could it work with pure IPv6 and no IPv4 at all? This is sort of IPv6 only. What's your general sense right now about our ability to operate without benefit of IPv4, setting aside those people who don't have IPv6 at all, and so it doesn't work without V4, but if they've got IPv6, do you think IPv6 only is feasible at this point?
From a consumer-facing internet perspective, then probably not. I'm sad to say, right? I think the fundamentals are there. I think people could use V6 to get V4. We can, if we have time, we could dive into that. But where I've personally seen the greatest amount of success, both firsthand and in kind of collaboration with others, is where V6 only is used for internal purposes. Managing large deployments of cable modems, mobile phones, etc. Hugely usable in that space. And there are many use cases to point to in the field today that are boasting tens of millions, hundreds of millions of devices.
So turning IPv6 on by default doesn't necessarily turn off IPv4, although we'll have to get to the point where we can either do that or it's being supported, I guess, by some sort of address translation technique. And am I correct that we already have ways of getting to IPv4 even if we're starting from an IPv6 address?
Absolutely. I mean, if you look at our friends at T-Mobile, absolutely a poster child for exactly this topology, this deployment methodology. Many of their devices, V6 only, if not all still very much allowing for equal access to both V4 and V6 content wherever it happens to be hosted.
So the obvious thing about IPv6, of course, is the enormously larger address space, although I confess to you I was a little nervous when I heard that they were going to start allocating 64-bit prefixes and 64 bits of address space for everybody to use, I'll call it locally, it seemed like that would consume it at a rather rapid pace, having been sort of stung by the rapid pace of IPv4 consumption. But let's set that aside for just a second. Some people say, well, IPv6 is more secure than IPv4, and I'm not so sure about that. What's your reaction to that statement?
I think from an implementation perspective, you're probably right, man, right? An implementation is an implementation. Some have made the argument that the vintage of the implementations have afforded either an opportunity for a fresh look and cleaner code, or less runtime, right? So we both know that after many decades of running code, that's how we really, ensure that it's secure. It's really through running it through its paces, right? The one thing that I can tell you for sure is that the vastness of the address space, it does present some challenges. It's like trying to find a piece of hay, a very specific piece of hay in a haystack, right? So that does present some interesting challenges, which I think over time, people will find creative ways to overcome. But I think you and I are generally on the same page. Like there's still many many decades for us to kind of catch up on around the longevity of running code and maturity that it affords implementations.
So let's talk a little bit more about efficiency, because my understanding is that when the IPv6 was finally concluded, as you will recall, there were many competing alternatives, and when it finally settled out, the v6 format had some simplifications. It took some things away that weren't needed or did not appear to be needed after our experience with v4. It looks like it's a more easily parsed format, and that might lead to some efficiency. Am I guessing correctly about that?
Yeah, I mean, at this stage, if I look way, back 20 years when, early days of v6, when routers were still moving packets in software, not hardware, there were many aspects of v6 that were still very rudimentary in nature, right? As you look over the years, how Slack, temporary addressing, privacy addressing, all these things have taken shape, very much hinging around the 64-bit boundaries as far as local area use is concerned. There's been a lot of predictable and frankly usable implementations that have hailed from the basis that IPv6 was born from.
So we know that IPv6 is not 100% implemented everywhere, otherwise we might not be having this conversation. And let's hope that 10 years from now, we will be having a conversation celebrating the fact that we've got it everywhere. Is there any pattern to where it is and where it isn't in terms of the parties that have implemented and turned on IPv6?
Yeah, I mean, when you and I had kind of, had the opportunity to kind of see one another a little while ago, we talked about this, right? And in the time period that trailed world IPv6 launch, we saw a lot of adoption. The largest carriers on the planet, whether they were fixed line or wireline, we saw giants in the content space, Google, Facebook, Netflix, etc., all adopt as well. I think over the past 10 years, man, and like, wow, it's been 10 years. Holy cow. And I really do hope that you and I are not doing this again in another 10 years. I think what we found was that the landscape across the internet has changed. 10 years ago, cloud. I mean, other than internally at in Google, and perhaps you could comment on this, there wasn't really like a commodity commercial cloud that people were kind of using heavily, right? But now they are, right? And I think you're finding that a lot of those folks, while some of them have kind of began their journey from a v6 point of view, there's still a great deal of work to be done as far as public cloud is concerned. And CDNs, I think folks like the names I've listed previously on the content side, they took it upon themselves because they had absolute control over their own infrastructure. But we still have CDN players of a massive variety that are still not really turning it on by default, which I think is a pretty important part of the theme that we've been talking about here. IPv6, on by default. One last comment, and then I'll hand it back. But if you look back to kind of the commitment that we all made, and there was really a very tightly knit group of folks who kind of engineered these events, we all agreed on by default, and leave it on, right? Even in some cases, consumers didn't even have the ability to turn it off. That's how committed, the initiative was, right? So I think we're there again, just a different set of players.
So, it's interesting to think a little bit about the architecture of the internet. And as you suggest, it certainly seems to be changing. One thing that's happening is that the cloud providers are building additional networking infrastructure in order to meet the internet service providers that our customers are connected to. And so there's I would say, a trend towards getting from the initial internet service provider into some cloud-based backbone network. Certainly that's true for us at Google. And I don't know to what extent that does anything to IPv6 implementation, but it does say that since a lot of the carriage is going to be on these cloud-based backbone networks, we want them to be fully up and running on IPv6 to be ready for anyone who turns IPv6 on at all. Do you suppose that it would be helpful for us to figure out how to show where V6 is running and where it is not? Because I think Jeff Houston at APNIC, who's their chief scientist, has been trying for some time now to capture information about IPv6 implementation. And maybe making that more visible would be a helpful step as we try to get to IPv6 on by default everywhere.
I couldn't agree more. The folks at NANOG, Vint, I had the pleasure to address the community back in the fall, and my first reaction to the folks was, wow, like we're still talking about trying to encourage V6 adoption here. I was like, some of us have been there, done that, right? And so I went digging, Vint, right? I went digging and found like we still have widely, aggressively adopted open source projects that start their life off in V4 and spend V4 only and spend many years that way. So to unpack a little bit your comment about Jeff, I think there's a lot of value in that, because what you'll find is that if you follow the trail of breadcrumbs, you'll find that a lot of that starts with the fact that people are just going to roll their deployments out with what they have. And if it were V6 on by default, I'm going to use Kubernetes as a great example. I know Kubernetes has made some fantastic enhancements as of late, but for many years now, it's really been a V4 only story, right? And when it comes to how people have chosen to deploy their products and services, a lot of that ultimately was being hampered by the fact that it was just, from a V6 perspective, is V4 only, right? So I think like you, I have an enormous amount of respect for Jeff. He's a great friend, and he's a brilliant speaker, right? And there's a lot of amazing work that he does that I think could help to very eloquently articulate kind of the blind spots that we might have in front of us today.
So let's imagine that we succeed in getting everybody to turn IPv6 on by default. I wonder what happens to all the hotels in the world that are essentially renting rooms because they have good quality internet service. I wonder what happens if IPv6 is on by default. How many guests would be calling saying, help, I can't get this to work. But that'll be an important test, and maybe that's something we should be pushing for. Let me move on to one other question I have about current implementations of IPv6. If they haven't been heavily exercised, of course, we don't know what the quality of the implementation is. And so one of the things that might happen is that if we go down this path and we succeed in getting people to turn IPv6 on as a normal process, I guess we should be prepared for a number of things to break and to encourage people not to turn it off as a fix, but to fix the problems so that we can keep running with IPv6. But maybe we'll have to push that pretty hard.
I think, Vin, if I may, a comment. I remember back in the mid, like 2005 timeframe, and before, it was pretty eye opening for me, right? Software switched, software packet movement, for V6, ASIC hardware based for V4. Lot of work to be done on just basic implementations. Even just configuring things like point-to-point interfaces between heterogeneous vendor environments was just not. It just didn't work, right? Fast forward 10, 15 years, a lot of that's been, water under the bridge for many moons now, and certainly scale tested. So part of me says, just based on my own firsthand experience, things of scale, nature, probably less of a concern for me. Things like edge cases might be varying by use case, right? So like, are there certain types of deployments that have very specific requirements that may not have been thoroughly vetted? And I think, Vin, that the only thing that I can share with you from my own personal experience is when you rely on V6 to run your business, you very quickly find out what doesn't work, and you come up with very creative ways to get it there, right?
Well,
and I think that's the key.
I agree with that. Certainly, everybody running around with mobile phones probably always has a V6 capability if it's going to work at all. I remember having, I made my engineers wear pagers after we turned our software over to the operations teams. So if things didn't work, the engineers got awakened as well as the ops guys. And it's amazing how quickly bugs got fixed. Well, one other thing, just to kind of round up here, the first observation that I wanted to make is that at Google, we discovered that we ran out of IPv4 address space for our own network, the internal network. The amount that we were able to allocate in private address space wasn't sufficient. And so we actually switched over to IPv6 in our internal network in order to allow continued growth. It gives you a sense for scale. I think that it would be really wonderful if we could identify, let's turn IPv6 on permanently day and try to make that stick, and then ask to get a good feedback mechanism so we can find out and get reported any issues arising so that everybody can learn from the experience.
I couldn't agree more. And just to use your example about the Google network, many others who've been confronted by the same, I mean, let's be honest, man, it's a business challenge, right? There comes a point in time where you have to kind of decide, like, am I going to continue to invest in V4, or am I going to invest in V6 and free myself from the constraints of V4 so that I can operationalize the same? Google's done that with its network. Large fixed and wireless providers have done the same for the large volume of devices that they have to provide IP to, whether it's a mobile phone or a cable modem. And if you just look at things like the public cloud, things like Kubernetes, very hungry when it comes to IP utilization. There are many analogs there that I think we can continue to learn from as we push forward.
So it sounds to me like you and I, anyway, are in complete sync. It's time to turn this on a permanent basis by default. And so you and I are now committed to that. Let's see whether we can get the rest of the world to agree with us. Meanwhile, thanks so much for taking the time to have this chat, John. It's always a big help to get real detailed responses from people like you who've got their fingers dirty in Phi. At this point, I think it's time for us to finish up our chat and look forward to a response coming from the rest of the internet world.
Thank you. As always, a great friend, a mentor. Cannot thank you enough for being here with us and being part of this conversation.